Welcome to True Projects. In this video, we are going to explain about the project that is detection of tooth position by YOLOv4 and various dental problems based on CNN with bite viewing radiographs. Before getting into the execution, first let us understand what is the project about. Think about this that you have been to the dentist and they quickly check your gums, maybe by taking an x-ray and tell you everything that it looks fine or perhaps that you need the treatment. But how do they know for sure? By diagnosing periodontal diseases, which is a common cause of tooth loss. It isn't as simple as it seems. It involves looking for certain signs like gum bleeding, sensitivity, bad breath, which can sometimes go unnoticed in the early stages. Traditionally, detecting these issues involves lot of manual methods like visually inspecting your gums, probing, and X-rays. While they work, they are time consuming and require lot of expertise. With over 3.5 billion people globally affected with this oral diseases, and the growing demand for dental care, these traditional methods aren't enough. They can miss early signs of disease or take too long to pinpoint the problem. That's why there is a pressing need for more efficient, accurate, and automated ways to detect and treat periodontal diseases before they cause permanent damage. And here, AI, that is artificial intelligence, has really made a big impact in this dentistry, especially in automating image analysis and improving the accuracy of diagnosing dental problems. Things like identifying tooth positions, detecting cavities, and even spotting periodontal diseases have all become much easier with AI. And it is like having an extra set of skilled eyes to look at the things might be hard to spot the naked eye. However, there are still some challenges holding back of its potential, full potential. For one image can vary in quality, which can affect how well AI model performs. Plus, before the AI can even start analyzing the images, there are often lot of manual work involved in cleaning up the data, which can take time. These hurdles highlight just how important it is to keep improving the technology so it is to be used more effectively and help make oral healthcare better for everyone. So, to overcome all these issues, this project proposes artificial intelligence to improve how we detect and classify dental diseases, and it works in two main steps. So, first, we will be employing YOLOv4, that is You Only Look Once version 4, which is a powerful tool for finding which teeth is affected by the disease. This helps to pinpoint the problem area so that right treatment can be applied. Then the system moves on to figure out what kind of disease patient might have. For this, we have employed deep learning models that are ResNet 50, AlexNet, and EfficientNet, which are all different approaches to analyze the dental symptoms, whether it is caries, periodontitis, or restorations. So, in nutshell, the system helps to diagnose dental conditions more efficiently and accurately, improving the overall care. Moving on to further improve the detection, we have incorporated YOLO V8. We have employed YOLO V8, which is the latest version of the YOLO model, to boost the accuracy of detecting the positions of disease affected teeth. This upgrade helps us to get even more precise with tooth detection part. For predicting the type of dental symptoms, we have combined several deep learning algorithms that are CNN2D and LSTM. So we have combined CNN2D and LSTM, that is bidirectional LSTM, which works together to select the best features for making the predictions. By using multiple algorithms for feature extraction, we can fine tune the process and get more accurate results when diagnosing dental issues. And moving on, as the front end, to develop the front end interface, we have used Flash framework. This makes it easier for users to interact with the system and test its performance. The interface also includes authentication mechanism, ensuring that user data is protected while they evaluate the system. This setup not only improves the user experience but also ensures that the only whole system is both accurate and secure. So this is the extension part. Moving on to the implementation. To implement this project, we have followed the steps mentioned in the flow of work. So first, necessary libraries such as TensorFlow, NumPy, OpenCV are imported for model building, data pre-processing, and image manipulation. Then comes the data loading part. The dataset is loaded from external source into the program for further processing. Then comes the data preparation. Here, images are resized to standard size to ensure uniformity across the dataset. And then comes converting images to NumPy array. So here image pixel data is transformed into NumPy array for easy manipulation and feeding into the deep learning models. And then the preprocessed image data, that is X, and corresponding labels Y, are saved for the future use for training. And then a visual representation of the dataset is generated to understand its structure and inspect a few example images and labels. Then comes data pre-processing. Here, image pixel values are normalized to a range between 0 and 1 to improve the model performance. And then the dataset is shuffled to ensure that the training and testing do not have any unintended patterns. Then comes data splitting part. So the dataset is divided into two sets. One is training set and the other one is testing set. So training set is used to train the models and testing set is used to evaluate the models. And labels are one hot encoded to represent the class categories in a binary matrix format for multi-class classification. So in model building, deep learning model architectures are defined, which involves developing convolution layers, dense layers, and activation functions suitable for image classification. Then comes model training. So the model is trained using the training data set where it learns to identify patterns and features within the images. And model evaluation. So the trained model is evaluated on the testing set to check its accuracy and general performance. Coming to the object detection, the YOLOv4 and YOLOv8 models are loaded for the object detection, and confidence level, that is a threshold, is set to ensure only the most confident detections are considered. And then YOLO process sample images to detect dental symptoms and mark the affected regions with the bounding boxes. After that, a function is defined to predict the dental symptoms using YOLO model, and then detected symptoms and bounding boxes are overlaid and on images for visualization, showcasing the areas of concern. So coming to front end, a web-based front end is developed using Flask, where users can interact with the system. This also includes registration and login functionality supported by SQLite database. And then comes the user part. So users, they provide images of dental conditions as the input for analysis, and that will be pre-processed at the back end, and it will be fed with the trained model. Finally, outcome will be displayed through the front end of the application. Moving on to the algorithms used. So here we have used multiple algorithms. So ResNet 50, AlexNet are the proposed models, and this is the extension model CNN 2D. So these are the models for classifying the dental disease, and we have incorporated YOLO models, that is YOLOv4, YOLOv8, and YOLOv5 for detecting where the disease on the teeth. Moving on to the requirements to implement this project, we need basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. To execute, we need to open the code folder which contains source code files. So let us open the code folder of the project. These are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? Let us open the custom data folder in which we have the data set. So here we have two folders. One is images and the other one is labels. Let us open the images folder first. So here we have two more subfolders. One is train and the other one is valid. Let us open the train folder. So these are the different X-ray images. So these are the images that we will be using for training the model for detecting the teeth disease. Let's get back. Here we have 416 images in the train folder, and images, we do have same kind of images in this validation folder too. Here, images which are in the train folder are used to train the model, and images which are in the validation folder, we use it for evaluating the model. So total 416 images are used for training and 71 images are used for testing. Let's get back. And coming to the label folder, in this label folder, we have two more subfolders. One is train and the other one is valid. Here in this label folder, we will be having files containing annotations and the labels for the objects in the corresponding images. So for the images which are in the images folder, for those images, we will be having object locations in these folders. So images which are in train folder, for those images, we will be having these label files in this train file. Here, each label file corresponds to an image file in the image folder. For example, the first label file, it corresponds to image file. Let's open the custom data image. So it corresponds to this image in the train folder. Similarly, for the second image, second label file corresponds to the second image. Accordingly, for all the 416 images, we have annotations in this label files. So total, we have 416 annotation files for these 416 images in the train folder. Here in this, we will be having the object class indexes. In image, we will be detecting teeth disease, right? That location we will be having in this files. So here each label file, it follow the YOLO format. For example, let us open first file. Here we have two lines, right? Each line represents a detected object. As there are two detections, here we have two lines. And each line follows the object class index. So here each line is specified by object class index followed by its bounding box coordinates. So these are the bounding box coordinates of the object 2. So this is the x limit, this is the y limit, this is the height, and this is the width. Here, 2 refers to one type of teeth disease and 1 refers to another type of teeth disease. Let's close this. Similarly, for the validation folder, in the validation folder, we have total 71 label files, right? So they are correspondent to images which are in the validation folder. Let's get back. Here in this model folder, we have the algorithm information that will be loaded into the project code during runtime of the application. And that algorithm information is stored in .h5 files, numpy files, and pickle files. Coming to the static folder, in the static folder, we have files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And then comes the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here in the test images folder, we have some images. We will be using them in the front end for predicting the disease. And here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have notebook.ipynb file. This is a Jupyter notebook file which contains codes, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And the last file we have is the signup.db file. This file is a database file which is used to store the user information. So this is all about the project. Now, this is all about the code folder. Now let us execute. To execute, copy the path of the code folder from the address bar of the file explorer. I'm copying the path. I've copied it. Now open the Anaconda prompt. It has been opened. Give the command cd, give the space and paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folders path. Now we are supposed to compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So this is the local host and this is the port. Now we are supposed to copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So here you can see a sign up link, right? We need to click on that. So we need to get registered. If you are registering newly, I have already registered, so I will directly log in. Click on login and give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see a choose file button, right? We need to click on that for uploading the images. So click on choose file. So these are the images that we will be uploading now. Let's upload this image. Click on open and now click on upload. So this given image, it will be pre-processed at the backend and then it will be fed to the train model and then train model will be giving us the detection and also the classification of the teeth disease. So here we got the detection. So this is the image that we have uploaded. Here, if you observe, there are two detections. So here you can observe, right? There are two affected teeth are being detected. So this part and this part. So that is why a bounding box is drawn around the teeth. So you can observe, right? Green color bounding box is drawn around the disease affected teeth. And that disease is periodontitis. It is the periodontitis disease. Let's try uploading some more images. Click on choose file. Now let us upload this image. Click on open and now upload it. Just wait for a while. Here we got the prediction. So here if you observe, we have detection. So from the image, we can observe that there are two places where teeth has been affected and a bounding box is drawn around the disease affected place. You can observe, right? And here we got the prediction as periodontitis. That means person is having the teeth disease and it is of periodontitis type. Let's check with the one more class. Click on choose file. Let us upload this image. Click on open and now upload it. Here we got the prediction. So here you can observe that there are two places detected. Here you can observe, right, green color bounding box is drawn around the teeth. And here it has been classified as restorations. So here if you observe, it has been classified as restorations. That means teeth disease is nothing but it is a restoration disease it is. Let's check with the one more class. Click on choose file. Let's upload the last image. Click on open and now upload it. So here if you observe, it is only detected in one place. So here if you observe, there is a detection and it is caries type. It is the symptom type is caries. Here disease has been detected, that is teeth disease has been detected and a green color bounding box is drawn around it and it has been classified as caries. Now let's check with the graphs. Click on graph. So here we have confusion matrix of the extension model, that is CNN by LSTM, that is bidirectional long short-term memory. And then here on x-axis we have predicted class and on y-axis we have true class. Moving on, this is the curve of YOLO V8 model, YOLO V8 training graph it is. And here we have accuracy comparison graph. Here on x-axis we have accuracy score and on y-axis we have algorithms which are trained. And this is the precision score comparison graph and this is the recall score comparison graph. This is the FN score comparison graph. If you observe, among all, extension has the highest performance metrics. Now click on sign out. In this way, just by uploading the image, that is teeth image, to the system, it will detect where that disease is in the mouth and then it will detect which type of disease it is. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.